Hi all. Today we'll be discussing the LeetCode problem of the day, apple redistribution in boxes. So you're given two arrays. First will contain the apple packets and second is the capacity. So here you have n packets where each packet can have any number of apples, and in the capacity you are given m boxes and each box can have some capacity. So this maybe has capacity 5, capacity 7, then 4 and 8. So you have to return the minimum number of boxes you need to select so that you can redistribute all these n packets of apples into boxes. Also, you note that apples from the same packet can be distributed into different boxes. So in this example, suppose you pick the box 8. In this box 8, you can put these both packets together. So 5 plus 3. And next you can pick this box 5, and in the box 5 you can maybe put this packet, and in this packet you can maybe put you can put one apple of this packet, so 1. And next maybe you can pick the box with capacity 4 and remaining one apple from this packet plus one apple from this packet. So total you needed 3 boxes to fill all the packets of apples. So the answer will be 3. But this might not be optimal because instead of 5, if you pick the box with capacity 7, then you can put this packet 4 and this packet 2 and this packet 1 as well. So in this configuration, you only needed 2 boxes. So you just have to return the minimum number of boxes you need to redistribute all these apples. Let's just look at the examples. So first you have apples as 1, 3, 2 and the capacity as 4, 3, 5, 2. So first I'll pick a box of capacity 5. In that I can put apple, this packet and this packet, so 3 plus 2. Next I'll pick a box of maybe capacity 3. In that I'll put the remaining packet, so total I needed 2, so output is 2. In the second example, my apples are 5, 5, 5 and my capacity is 2, 4, 2, 7. So first I'll pick the capacity 7. In that I'll put this packet with 5 apples, and I still have 2 space, so I'll put 2 apples from this packet. So from this I've removed 2 apples and I've put it in this box. So this is done. In this 2 apples are done. Next I'll pick the box with 4. So here 3 apples are remaining, so I'll put all the 3 and then 1 apple from this packet. So 1 apple is removed. Next, in the box with capacity 2, out of this 4 I'll put 2 and the remaining 2 I'll put it in the other box with capacity 2. So total I needed 4 boxes, so the answer will be 4. Now let's go over the constraints. So the apple's length can be from 1 to 50 and the capacity can be from 1 to 50, and both apples of n capacity of I also will be from 1 to 50. Also, it is guaranteed that the input is generated such that it is possible to always redistribute the packets into the boxes. Now let's go the approach. So since we can split apples from each packet, so suppose we have apples like this, 1, 3 and 2, we can consider all the apples as a single packet. So I can just take a sum of all these apples and the sum will be 6. Now these 6 apples I have to distribute into some boxes and I have to minimize the number of boxes. So the logical way is to start filling from the greatest box. So in this example, first we sort the capacity and then we iterate from the behind. And first we pick the largest box, which is 5. And in this 5, we'll try to fit all these apples. So only 5 apples are fit. So we still didn't reach the total 6. So we'll move on to the next box. So the next box will be 4. So in 4, we can fill up to, 5 plus 4, the total capacity we can fill is 9. So at this point, the capacity is at least greater than or equal to the total number of apples. So 2 boxes will be our answer. Now let's code the approach. So first let me take the total count of apples. X in apple. Now let's sort the capacity. Sort. So let's take 2 variables which will store the boxes count. Initially, we have 0 boxes and let's say capacity. And let's start iterating the capacity array from right to left because it's sorted in ascending order. 2 capacity dot -1. Yeah. So first we pick the last box. So in the capacity, we'll add capacity of I. And since we have picked this box, we need to increase the boxes count. So at any point, the capacity will be greater than or equal to the total number of apples. We don't need any extra box. So we can simply break the loop. And at the end, just return the boxes. Let me submit. Yeah, it works. Finally, let's do the time and space complexity analysis. So for the time complexity, first we are iterating on the apple, so this will be order of n. Then we are sorting the capacity array, so this will be MlogM, and again we are iterating on the capacity array, so this is order of m. So the total complexity will be order of n plus MlogM. And coming to the space complexity, it will be constant because we have not declared any arrays, only a few variables. So space complexity will be order of 1. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.